So the usual IO stream, and would it be wrong if I returned something other than 0? In other words, can I return 2? Yeah, not a big deal. 2 is an integer. All it wants is an integer. So while we're at it, I am going to do a variable initialization with multiple assignments. What does multiple assignment mean? You are assigning several variables simultaneously, some value. So I'm going to go with double var underscore a equals var underscore b equals var underscore c equals 2.0. So a, b, c, they all would have the value 2.0. Last time we did a case where we tested to see if the number that was entered is even or if it was odd, and we accomplished it using what operator? Modulo, specifically what modulo? Modulo 2. I'm going to have another variable. I'm going to have int I'm going to call it mod val. So I defined variable a, b, and c as double for a reason, but we know that both numerator and denominator, or in other words, the first operand and the second one, have to be of what type? Integers. So let's just go ahead and do var underscore a percent var underscore c, b, and save it to, oh well, we don't want to do var underscore b, just do var underscore a mod 2 and save it to mod underscore val and see what happens. I want you to try. That is not going to run because it is not the proper data type. Yet if you want to use modulo, if you're adamant about using a floating point data type, what would you use? Fmod. But if we want to use Fmod, can I use it directly or do I need something else? I need CMath. If without CMath, I can't do Fmod. Of course, what we have learned so far this semester is depending on whether you use CLion or whether you use W3 schools. Several things are included in different platforms, so sometimes it may be in CMath or you can access it from math.h. It's going to vary. So what I'm going to try and do is do static underscore cast and put int and then do c mod 2. The first glaring error is var underscore c because there is no such thing variable C that's initialized. Second, static cast. Static cast is a function, so you can either put it within parentheses or you can leave it as is. But something has to go between the signs that we use for IO stream. That would be the data type. So you can put parentheses around static cast, but you can't put the less than greater than sign. It's a common mistake to switch. Wanted to show you that part. Run now, we've fixed the var underscore C issue. The static cast is trying to convert the double and register it as, take a guess, what value? Integer. Did it work?
When we initialize all the doubles, it doesn't work.
It doesn't work for you?
It says var v was not declared in the scope. You need var.
It is not reading a direct initialization. So there's definitely an error in line 9. So what I'm going to do is try this instead. Multiple assignments are permitted in C++. I'll be surprised if it doesn't work. But then some weird things have happened here. Oh, good. It worked. Did it work for you? The entire code. Done. That we had in terms of having an integer with mod has disappeared when we did static underscore cast. That operation is what we call typecasting. So typecasting is possible within align data types. In other words, if you want to cast numerical data types, you can either promote or demote the data type. For instance, double is at level 1 compared to integer. I'll just put it this way. If you want to cast an integer to a double, you are promoting. If you go from double to integer, you are demoting. But of course, we have done demotions from double to int without using static cast. Do we remember how? Do you follow my question? We have demoted from a variable and its value from double to int without using static cast. Jake? Multiply the... So I think this is what Jake is trying to say. For instance, if I created another variable, var underscore d, and simply said, well, declare the variable as int var underscore d, and set var underscore d equals var underscore c, then naturally it is going to move that double to an int. Yes, we've seen that before. If you have an integer declaration and you assign a floating point value, it will drop the floating point part, truncate it, and keep only the integer part. Yes? So that is one way where we don't have to demote it does it automatically. This should run, and it did run. This is what I want you to do. Get an input for var underscore c prior to line 15. It could be any value, double, integer, because we are casting it. Once you evaluate mode underscore val, I want you to test to see if that number is even or odd. Just the if statement. We're going to test if it is even. If it is even, perhaps it will print the output. Otherwise, it does nothing. It just returns an empty value. So, want to get an input. Enter a number to test. Going to get it for var underscore c. So certainly one can insert another line, define a variable, save its output, then test for it, or not define a variable at all and put the condition inside the if. The way we did it, we sort of did it in a different manner where I got a double value, converted it to int, then found the mode. But not necessary. You can define it in a different way. Like last time, you could use bool. The reason why I did it, the way I did it, is to demonstrate line 18. Typecasting. Should I put the terminator semicolon in line 20? Should not. It's a very common mistake. You shouldn't, because what does an if statement expect immediately after the condition? A curly brace. So the compiler is going to look for a curly brace immediately after that parentheses, and if it can't find it, you'll get an error. So the number is even. I was very impressed as I went around some introduced quotes, single quote. So we know we can escape it using backslash. It's best to escape. In this code, it should work without escaping. But then C++ is tricky. I shouldn't say tricky, it's finicky. So the reason why it's going to take offense in some cases is because when we initialize characters, we use single quotes. So you might run into problems. So let's see if this works. So control, it's probably not going to work because I'm forgetting that. Number to test, give me a number.
23.
What's up with you and 23? 23 is odd. Nothing happens. Do it one more time. Give me an even number. 22. The number is even, right? But we're not testing for odd, and last time I demonstrated, sure, we can test and put something immediately after a statement that says it's odd, but it is going to throw both outputs. To avoid that scenario, one must put curly braces. If you refuse to put curly braces, what can we do? We can simply use an else statement. I believe I did show you last time inserting curly brace will test for whatever that is inside the if block, but once it gets out, it is going to print whatever that's there. So if you have a single statement, you can use if else in this manner. So it is going to test for whatever condition that is in the if statement. If it fails, it is going to move on to the else statement, whatever that's in there. As long as it's a single statement, it is fine. This should work. We will see. It did. Give me an odd number other than 23.
23.7.
Now, Jordan gave me 23.7. It's not an odd number, it's not an even number, it's a floating point number with an odd integer part. It is going to cast it to what value in line number 18? 23, and print the result as the number is odd. Even number. Jake? 22.7. 22.7, it is going to cast to 22. The number is even. Good? Okay.